Hi everyone, this is John from Phoenix, and today I'm going to walk you guys through how you can evaluate and experiment on an image classification pipeline using Phoenix. We recently added multimodal support to Phoenix, so we can now display these rich images within the traces that you see in the platform, and so we're going to take advantage of that and show you guys an example of how you can not just show those, but also kind of evaluate the performance of a model or pipeline on those different images. So what we're going to do for this case is I've got a notebook that we'll walk through that just does kind of takes a data set of images, runs them through a classification task that we have, and then evaluates how close that task does at classifying the images or what's in those images to some ground truth data in our data sets. So we're using experiments in Phoenix, we're going to use tracing, and then we're going to use this new image support that we have. So in this notebook here, first thing we're going to do is just install a few dependencies, just basically Phoenix, the instrumentation library we have, and then we're using OpenAI in this case, so we use OpenAI, as well as the datasets package from Hugging Face, which is where we're going to get our dataset from. Then this next kind of block here to connect to Phoenix, this block is going to do a couple different things. We've actually started using this in a lot of our examples, but essentially what will happen is if you have a Phoenix API key saved to your environment variables, if you've got one present, then we'll try to connect to that cloud instance of Phoenix. And if you don't have one there, then we're just going to launch a local version of Phoenix. There's a bunch of different ways you can host Phoenix, so this is kind of our attempt to make this a little bit more sort of adaptable to whichever way you're using it. In this case, I've got a key saved locally, but I want to force this to use a local version of Phoenix just to kind of show you what that looks like cleanly. So I'll run that here. This is going to launch a localhost version of Phoenix on my localhost 606. And then from there, I'm actually going to use another new thing we have in Phoenix. We have a lot coming out right now. We're going to use this register function, which is great. And this takes the place, if you've used Phoenix before and you've seen all that boilerplate code that's going through and adding a tracer provider and span processor and all this stuff, that's now replaced with this method that we have here. So now we're connected up to Phoenix and we can continue on in our example. So next up, I'm going to pull in a data set from Hugging Face. And if I actually jump over to here, I'll show you guys what that looks like. I'm just using a kind of very basic one, 10 rows, some different images, a couple different kind of classifications of what they are. Images are pretty grainy, so that might give our pipeline a little bit of trouble, but we'll see what that turns into a little bit later on. And so now if I jump back over, if I look at our data frame that we got from that, I'm just pulling the training split and then sending it to pandas. What I'm noticing is that we've got this sort of dictionary object for the image with bytes as a key, and then what looks like kind of a encoded string for the image. And then our labels are also going to be numeric as opposed to like a human readable text. So first thing I'm going to do, and usually this is going to be the case if you're kind of running with any kind of image data, is that we got to convert this into something that can be usable. Phoenix right now is set up to accept base 64 encoded strings for images, as well as just a URL to the image, like a web URL. So we'll work similar to a lot of LLMs that can also accept images in their calls. So what we can do is we're going to go through to a few things here. First, I'm just going to pull out the bytes object and make the image column just that actual bytes object as opposed to the sort of dictionary. And then I'm going to encode it, base 64 encode it, and then make sure that it's UTF-8 encoded as well. And so we'll kind of convert that into the format that we can read. And then we also tend to like when there's this prefix to the data beforehand saying what each row or what each kind of image looks like there. So if I run through all of that, and then next I'm also going to add this label map. This I just pulled from the Hugging Face database itself of what each number corresponds to in terms of the actual classification label. And so now if we look back at our data frame, this is much easier for us to use. We've got base 64 encoded images with that little prefix that we like, and then we've got human readable or LLM generable labels that we can compare to. So now from there, we're going to go in and we're going to just display one of these images, make sure it can appear correctly. We've kind of got to do a little bit of the inverse there. We've got to actually decode it so that we can display it within a Python package. But it looks like that first image is popping up correctly. Cool, so now our data frame is good to go. This is our set of test cases that we're going to experiment with. And so now I can actually upload that into Phoenix. And what you'll see if I click on this, it'll go to my local instance. I've now got this data frame of experiment kind of test cases that we can track with the image URL or the base 64 encoded image, and then the output label that we have. And I've set that image as our input key and our label as our output key. So that's what we can use to compare to. when we run the experiment. Now, another thing I'm going to do here as we go to defining our task is there's a set of environment variables that Phoenix will also pay attention to and OpenTelemetry uses that can define a lot of things like the max size of images, the sort of like minimum size of images that you're going to use. You can also define whether or not you want to display images, some kind of Boolean variables like that. All of this goes under what's called a tracer config or a trace config. And so we can set some of those. I'm just going to use one here to make sure that our grainy images, which are probably not going to be very big anyway, are still going to be able to display. So we want to up the max image size length, just in case. And now we're using OpenAI, so I also want to trace OpenAI calls so that we can make sure we track all of the stuff that's happening as we look through our experiment. So we're going to use Phoenix's auto instrumenter here to do that. So that means that any OpenAI calls are going to show up in our Phoenix instance. And now we can define the task. So the task is like, what are we going to do to each row of our data set to generate the output we want to compare against that ground truth. So for us, this is pretty straightforward. We're just going to make a call to, in this case, GPT-4o Mini with this prompt here of what's in this image, respond with a single word, and it should be one of the words that's in our sort of map of values from earlier. So we want to make sure it sticks to one of those sets of words. And then this is the other new piece here. We're also going to pass in the image URL. And with this image URL here, this call to OpenAI will cause the image to show up within Phoenix. So whether or not you were using an experiment, if you just made this call after tracing with OpenAI, you would now see that kind of rich display of the image there. And then last thing I'll do is I'm going to pull out the response, send it to lowercase, just so we can easily compare with our ground truth. Okay, so now we have our data set, we have our task that we can run, and then next up we're going to run or set up an evaluator that we want to use. So this is once our task runs over our data set row, what are we going to compare it against to generate some sort of score, or how are we going to generate that score or evaluation for how well that task did. In this case, we have ground truth, so this is really easy. We just are going to compare it to the ground truth, basically. None of our strings are close to each other. It's not like we want to do any sort of like similarity matching or anything like that, but you could do that here as well too. You could run a full LLM as a judge, kind of evaluation here, whatever you want it to do. But the way that our experiment pipeline is set up, will serve you the expected value, will serve you the generated output, could also serve the input or anything else around that particular test case. All right. And so now we have all of our pieces in place. I'm going to go ahead and run this and we'll talk through it. And so now what we're going to do is I'm just basically patching the event loop here to run asynchronously so that this goes a little bit faster. And then we're going to call this run experiment function, which will take our task, our evaluator from earlier up here, and then our test cases, as well as just some metadata to kind of label everything. And what it'll do is it'll run every row of that data set through the task, and then the output of that task, as well as the expected output through the evaluators to generate some sort of score. And so you can see we've now completed our experiment, and I can go and jump into Phoenix. And let's blow this up so it's a little easier to see. And if I go back here, we've got our data set that we've used, and we've got our examples from before, and now we can view the results of our experiment. And it looks like it actually aced it in this case. So I can go in here and I can click on this, and one thing that comes with these base64 encoded strings is that they are very long. So I'm going to jump us all the way over to the right here. And then what you'll see is we've got our reference output, that's our expected value, and then we've got the output that was generated by our pipeline here. So if I jump into that and look at the actual trace, what you can see is we've got our image getting rendered within the trace here. This is our very generic, or very grainy image here of a car. And so you can see that being passed through along with the prompt, and you can see the response that we're getting back from our model here. So from here, what you could do is you could actually go back into the code, and if you wanted to, you could start experimenting with modifying your task in different ways. Maybe you wanted to use a different model, so instead of using 4o Mini, you could use a smaller model, see how cheap you can get, given that 4o Mini did so well in this case. Or you could start modifying the sort of other behavior within your application and keep the data set and the evaluators the same and use them to sort of benchmark how good your performance is over time if you keep switching out models or switching out logic from there. And again, the image support that I mentioned here, that'll work with all kinds of different calls that you want to make. So You just make a base call to OpenAI using some other code here. As long as you're tracing that with Phoenix, that will show up in the dashboard. And you can even include multiple image URLs and things like that as you go through and trace your different applications, and we'll render them in a nice gallery view for you there. So hopefully this gives you an idea of how you can set up an experiment in Phoenix, how you can trace images in Phoenix, and how you can use the two here combined to come up with this image classification pipeline. If you're enjoying Phoenix, please consider giving us a star on GitHub. It really helps us continue investing in all the nice product updates that we've been able to release. And if you haven't tried Phoenix in a while, now is a great time to test it out. We've put a bunch of more usability features in there, everything from that new kind of register method that you saw to revamping a lot of the getting started process within the dashboard. So check it out if you haven't been there in a while, and thanks for all your attention here. Appreciate it. Have a great day.